Hello guys, welcome. This will be like a short video on a very important topic. I just want to talk about, let's say, scientific publication, and more importantly, it's not just about some specific technical aspect of scientific publication, but rather it's a very important question. So first of all, let me present you the question. Do you think we should move towards open science? I mean, most of you are gonna say yes. I mean, personally, I personally would say yes, and that's what I'm gonna justify, like why I would say yes in this video. So first of all, what I mean by open science in very briefly is that the model that we're following is that to publish a science article that people will take seriously. I mean, you can publish whatever you like on your blog, on your website. I mean, you can open a blog, for instance, on, I don't know, Blogspot and all that stuff. You can open a for free. You can open a week's website, for instance, for free. And if you are ready to pay a little amount of money, you can even get your own domain, your own website, and nobody's preventing you. I mean, you can publish whatever you want. Even you can publish things which are like pseudo scientific, not real science, which are not accurate, but you can publish them in your website. But the thing is that nobody's gonna read those articles. I mean, very few people, maybe some of your friends, maybe people you shared them with, but the scientific community is not gonna take your ideas seriously in that case. If you want your ideas to be taken seriously by the scientific community, number one, they have to be accurate, of course, and number two, you have to submit them to like big journals, real science, like peer reviewed science journals, and then the articles go through a very detailed, extensive review process, and like only if they're accepted, then they're published. Sounds good? Well, only problem is that in reality, especially like in real academia, there are a lot of malpractices and also a lot of, let's say, problems with the system itself. For instance, if you want to publish your article, you are the one who is the researcher who have done some work, let's say for 1 year, 2 year, whatever, and then you have to pay a huge amount of money, huge sum of money, and not all the time. Sometimes maybe your institute, your university can take care of the fees, but not always. To get your article published open access. I mean, if you don't publish open access, nobody can read your article essentially, or maybe they have to pay, like the readers have to pay $50 to read the article or something, which makes no sense. And if you want your article to be openly accessible to all, which is what you would usually want, because you want citations, you want people to read your work, and maybe you want some other scientists to work on your work, and they will cite your work, and that way your citations, your stats as a scientist will also go up. That's what you essentially want, right? But to publish open access, you like they charge the big journals, for instance, Nature and all. They, like, for instance, there are journals who charge like 8,000 euros or something for to publish open access, which is a huge. I mean, it doesn't make any sense. But at the same time, if you don't publish in those journals, people are not going to take you seriously. I mean, there are some articles, like there are some platforms like Archive, where publication is completely free and open access, as well as there is a little bit of regulation. It's not like, I mean, it's not usually what we understand by peer review, that but it's actually a kind of very tight regulation. For instance, to submit to Archive, you need to have yourself endorsed by someone who publishes in that category, and then you have to, then the article also goes through a bit of check. You cannot just upload. It's not like a open research repository, or not like a website where anybody can upload any PDF they want. Not that. But at the same time, it's not a full peer reviewed journal in the traditional sense. And I personally love the concept of Archive, actually. And there are even some other platforms which are less strict as compared to Archive. They're more open, and some people are like, okay, it's good that they don't charge anything, but the problem with these kind of platforms is that anybody can upload anything they like, and that means there would be a lot of junk, there would be a lot of nonsense articles. I totally get it. But so the question is, it seems that we are drift, like we don't have, the best option would be to have a middle ground. Like there should be some amount of filtering, some amount of regulation, but it should not be the case that is that like money and the peer reviewers are controlling the future of science, because that's what's happening. And even scientists, they have they have adopted a lot of malpractices to get around this. For instance, there is a very like a practice of citing yourself, or maybe an article. For instance, I submit an article to a peer reviewed journal, and maybe someone has not even worked on that idea with me. I don't even know that person, maybe, but they, let's say they are very, like they have a lot of influence within the journal. They will add their name as a co-author, or in some cases even the first author, even though they haven't not even worked on it. It's my work, and they will say that, okay, if you don't want my name as your co-author, then your article will not be published. And this is a very difficult situation, because scientists, I mean, especially junior scientists who are starting their career, they need to get it published. And So they're kind of in a desperate situation, and that is like these kind of people, they take advantage of this desperate situation and exploit the young scientists actually. So which is very unfortunate, but it happens. I mean, a lot of there are a lot of such stories which we hear. And then, for instance, an article, there are, let's say, 500 or 600 authors in maybe not, that's a bit too much, like I think there was an example, there was a rare example, but I think it was the article with the most number of authors. It was actually something around that, I don't know, 100 or something, like in the order of hundreds, I don't know. But I mean, even if an article has, let's say, 30 authors, okay, I understand if it's a really big project with a lot of collaborators, it's possible. Like some people are, like we have, let's say, collaboration between 5 or 6 labs. In each lab, let's say 10 people are working on different aspects of the project. I'm not saying that's not possible, but at the same time, some people use this to as a like a malpractice, because for instance, if you have an article with 30 authors, maybe some of them are just there because of their authority or their influence, but they have not even worked on it. But still, since their name is officially there in the paper, they add a publication to their profile. And every time that article gets cited, all these authors will I mean, their citations will increase, and it's kind of like a network. And there are ways to manipulate the system, and a lot of scientists have adopted these malpractices, unfortunately. Now the question is, so what it appears is that the peer reviewers and this system, these journals, and money, essentially, because you need a lot of money if you want to publish open access. So this is what's controlling the future of science. So it's almost as if, let's say, there is a bias. It's not as if there is a bias. There actually is a bias, and it's a slowly growing bias. For instance, there are a lot of biases when we talk about scientific research. One bias I discussed recently, maybe in the last 2 or 3 months, in one of my YouTube videos, was about positive results and negative results. So, for instance, negative results are usually not published or not accepted by journals. So, scientists who get negative results don't even bother submitting their articles, and this is a growing bias in the published literature. What I mean by positive and negative results, just in case you are wondering, just to keep it short. So, basically, when you start working or researching on a hypothesis, ideally you should have no bias. Like ideally, you don't know whether your hypothesis is correct, is true or false. So your research can reveal either it's true or it's false. But in reality, what happens is that, especially if you're working on a problem which has industrial consequences and stuff, like an applied problem, maybe the ones who are funding your research, they want yes for an answer, or let's say they want no for an answer. Let's assume they want yes for an answer. So what you often do is that, since you are a scientist, you have to get the money for your research. People often can tweak, or let's say manipulate the statistics a bit to produce a yes, but it's still biased. You could actually get a no, but you want a yes. But in ideal research, you should not want anything. You should just explore your hypothesis, and you should be ready for both answers, either a positive result or a negative result. And negative results are important because, for instance, maybe you don't find something new, but at least you try out a path and you don't reach anywhere. But that means you actually demonstrate that this path was not the correct path for this problem. So that's not a new result in that sense, but it's still a new result in a way, because, for instance, you want to reach to destination. Let's say you want to reach a destination A, and you start from a point, let's say 0. Let's say you want to reach destination B, and you start from a point A. There are many paths from you don't know your destination, by the way. You start from A, so you know that I am at A right now, and you don't know where B is. There are a lot of paths leading from A to B, and you don't know which path will actually lead to B, because some paths, let's just as a thought experiment, let's say some paths do not lead to B, or some paths have deadlocks and stuff, but you don't know which, like, of course. So let's say you start working around a path, you just choose a path and you don't reach B. So that's technically a negative result. But that doesn't mean you're a failure, because you at least, if that negative result is published, then there will be less bias in published literature, because then researchers who are working on the problem, or who will be working on the problem in the future, can read your paper and understand that, no, so this guy already tried this path and he didn't reach the destination. That means it's the wrong path. Let's exclude this. That's a good thing. But no, usually these kind of negative results are usually not seen in a very positive way. They're not published and all. So there's a bias. That's a different thing. But the bias I'm talking about right now in this video is that, so scientists are adopting malpractices, like citing oneself, or maybe including names of people who have not even worked on that article, on that project, on that research project. And this is growing day by day, because the young scientists, they have no choice but to agree to these kind of things, because they need publications, and they're being exploited constantly. So it's growing day by day. And this is introducing a bias, because people who are, let's say, a bit old or have a lot of influence but not working at all, their names are everywhere. So if you just look at the statistics, then they appear to be like very great successful scientists, lot of citations and stuff, but they're just manipulating the system instead of doing real science. And this bias is growing, and even the young scientists who have been exploited, when they grow up and become influential, they will be following in the footsteps, and they will be keep doing the same thing. And it's a very, like, it's a very, very, I should say, negative, and like a vicious cycle. We have vicious and very negative cycle that we seem to have created, right? And the bias is growing. That's one bias. Another point, another aspect of this same problem is that the peer reviewers in a way get to decide the future of science, because if you publish in peer reviewed journals, only then you'll be taken seriously. If you upload your work to, let's say, an open research repository, you'll not be taken so seriously. But if you submit your article to peer reviewed journals, then the editors who will be editing your article, the reviewers, actually, they get to decide whether the article should be out there or not, which is fine to a certain extent, because of course not everything is worth. I mean, there should be a certain amount of filtering, because today it's already a lots and lots of information. Every day hundreds of research papers are being published. And I mean, for instance, when I talk with the old professors, they are like, when we were young, every week or every month only one journal came out, and the journal was the thin, like maybe there were 5 or 6 articles, and we just went through those few articles, and we were more or less up to date with the literature. But today, I mean, every single day thousands of articles are being published. Even though you're working on a particular project, even if you consider articles that are relevant to your work, even then, like every week, let's say hundreds of thousands of work is being published. It's not possible for you to keep up to date. And on top of that, if we like allow anyone to publish anything, that will create more noise, and that will make things more difficult. So I understand the point, that the guys who say that there should be some filtering, there should be some review process. I totally understand. There indeed should be. I totally understand. But at the same time, it's worth wondering. And I mean, I would personally believe that this I personally believe that this also has some benefits, if we adopt a system where in a way anybody can publish anything they like. Of course, that increases the noise, and here we are essentially saying that there is no regulation at all. And there are some open research repositories where actually you can upload whatever you like, even though you'll not be taken seriously by the scientific community, not because they are not treated to be on the same level as peer reviewed journals. But they're completely free, and there is no regulation as such. Now the question is, so you might think that, okay, maybe I have done some really good work and I can upload it there, but at the same time, it's the same platform where people upload a lot of nonsensical stuff. So if I put my serious work there, then I'm kind of diluting the level of my work. And that's true. I mean, that's why, I mean, that's a valid concern. I mean, totally. But at the same time, I mean, the real scientists, the ones who are real scientists, they can figure out for themselves if an article is totally nonsense, totally like just junk, rubbish, or if it has something, right? So of course, maybe there will be a lot of nonsense publications if we adopt a model that's completely open access, like I mean, completely open science. Anybody can publish whatever. But at the same time, I mean, the non-scientists, very few of them actually will take the trouble to write a very serious looking scientific report which is actually rubbish or pseudoscience and upload it. Some will, but I mean that number would usually be very small. And I mean, if you talk about junk, or let's say the internet, I mean the internet is already filled with junk. Look at those, for instance, those, what do you call it, Instagram stories, Instagram reels and all that. That's junk, but that is not being regulated, right? So I mean, because the biggest advantage, especially long term, of this model is that it in a way it keeps a natural check on the bias. Why? Because it's almost as if like natural selection. I'm talking about evolution, natural selection, Darwin's theory essentially. So if you don't regulate at all the number of articles, the quality of articles, no peer review, nothing. So of course there will be some junk. I totally agree. There will be some junk articles. There will be some nonsense articles. So these are just some mutations. Now in a biological, let's say in nature, not all mutations in biological creatures are good. I mean, actually very few mutations are actually beneficial, and very few mutations actually survive after a few generations. Most mutations are just random, which don't serve which are not actually beneficial, which don't serve a purpose, or in some cases some mutations can also be harmful. So these mutations are usually washed out after a few generations. It's the same thing. If people upload a lot of junk articles, maybe initially there is no regulation, so these are just the bad mutations. But after a few years, most of the scientists, I mean, no, they will not even read or click or cite these articles. And if the articles don't get cited a lot, or don't get a lot of reads, then automatically the system will flag down those articles as, look, these are, maybe they will still be there. I mean, they will, maybe they will not be taken down, but nobody will even bother, so that doesn't matter a lot, right? And if you talk about like flooding the internet with nonsense, well, if that is your concern, stop. Then first of all, you should stop the guys, stop people from making nonsense Instagram videos. I mean, those videos, those reels, they are like some MBs or megabytes or even more. I mean, if you really think about digital resources and stuff, I mean, a PDF, even if it's a junk article, that's a 70-page article, it will be a few hundred KBs or maybe 1 or 2 MBs at max. So that's not, that argument doesn't hold up really. So I mean, the internet is already filled with junk, so you're not really solving the problem if you just regulate the scientific articles or some PDFs. And in a way, I think even reading a, reading a pseudoscientific article at least helps you appreciate why it's pseudoscience. So in a way better than watching Instagram reels, for instance. Just a okay now. So that's the thing. So if you let people publish whatever they like, anything at all, that is the thing. So then that is called like it's a very extreme model, like no regulation at all, but at the same time it allows like kind of spontaneous natural selection of I mean, let time decide which articles survive. It's natural selection. Don't let bias get it. I mean, don't let the peer reviewers decide, or don't let money and don't let this kind of malpractices which are going on, don't let it decide the future of science. Let time decide. If you publish an article which is just rubbish, after a few years, maybe after a few generations of scientists, that article will anyway be washed out effectively. Nobody is going to read it, nobody's going to take it seriously, even without review. So yeah, it's a long term vision. Maybe in short term it will create a lot of confusion, a lot of chaos, but I mean, the way things are going, sometimes I believe that, I mean, indeed it's something, it's worth discussing. It's still a very relevant open question. I'm not trying to say that one is clearly the better, I mean, one is the better path than the other, because both have their pros and cons. But yeah, it's something just wanted to discuss. We should definitely change the current academic system, but the most safe option short term would be to slightly relax the regulations and especially take care of the malpractices and this charging a lots of fees, lots of publication fees for open access. But a long term vision could be, at least could explore in slight, like explore slightly this idea of like allowing open science at all, because don't, like, it's kind of like okay, like this natural selection we discussed. And okay, just something I wanted to discuss. It's already 17 minutes, and I really don't want to make this video very long like the other ones, whenever I usually start by saying that okay, it's gonna be 15 minutes, but I end up it's like 40 or 50 minutes. But yeah, I would like to open like hear your thoughts about this. And I mean, thanks for listening.